Section 9.5 Day 1 is we are going to be working with regular polygons. So to calculate the area of a regular polygon is our goal for today, and we're going to be finding missing measurements when needed. There are two methods to find the area of a regular polygon, and today we're going to go over method 1, and then next week we're going to go over method 2. And then once we've gone over both of the methods, you can choose whichever one you want to use to calculate the area. Sometimes it'll be easier to use method 1 versus method 2 and vice versa. So you can decide which one you would like to do. First, we're going to start with some vocabulary. So here's a picture of a regular polygon. This one just happens to be an octagon, but it can be any number of shapes. Or any number of sides, sorry. So some vocabulary word is a vertex, and this is the point where two sides meet. So on this one, you can see all of the vertexes where the corners are on our octagon. Those are all of our vertexes. The next vocabulary word is radius, and the radius is the distance from the center to a vertex. And the important thing is, for it to be a radius, it has to be from the center to the vertex. And you can see that right here labeled in our diagram. And the reason that it's called a radius is because we could form a perfect circle around that polygon, and we would see that all of those points would land on a circle. Let's see, shapes. Let's try to get one drawn in here. Oops. And let's just select that. Put it over our object. And I know this isn't a perfect circle because it's from an oval shape. Alright, so that's going to be about as close as I can get it. But you'll notice, looking at this, that all of those points, those vertices, line up on this circle that's highlighted. And so that's why we can call that a radius, just like we would from the center to the outside of a circle. So then the next word is, vocabulary word is an apothem. And the apothem is from the center, so the distance from the center and this is to a side length, and it's perpendicular. So the distance from the center perpendicular to the side. And when it goes perpendicular to the side, it actually cuts that side length in half. And that's going to be useful to us because that's going to help us calculate the area of a polygon. Alright, so make sure you get that definition drawn or written down on our shape. And the last vocabulary word is central angle. And the central angle is formed at the center between two consecutive radiuses. And consecutive, remember, is one right next to the other. So in this one, our central angle is drawn in between these two radiuses. And again, we're going to be using that central angle to help us calculate the area of our polygon. So that's why it's important that we know all of these different vocabulary words. So now we're going to go through a couple of examples. Example 1, we have a diagram ABCDE. And this is a regular pentagon, and it's inscribed in circle F. And we are going to be finding the measure of each angle. So the first angle that they would like us to find the measure of is AFB. So I'm just going to highlight that so we know exactly where we're looking at. So they want us to find the measurement of AFB. And if you notice, that is between two different radiuses. And if we were to draw in the rest of the radiuses going all the way around this pentagon, we would have a total of 5. And because this is a regular pentagon, all 5 of these angles are congruent to each other, which means going all the way around in a complete circle, there are going to be 5 angles that are equal to each other. So to find the measurement of this angle, we're going to take 360 degrees, which is the distance going all the way around the circle, and we're going to divide it by 5, which is the number of side lengths and the number of central angles that can be formed. And when we do that, we will find that this angle is equal to 72 degrees. Our next example, they want us to find the measure of angle AFG. And the measure of angle AFG is going to be half the distance or half the angle measurement of the central angle. And the reason because it goes from our radius to an apothem. So those are going to be half the measurement of our central angle. So we already know our central angle is 72, so we're just going to take that and divide it by 2. And that will end up being 36 degrees. And now that we have that, we can go ahead and find our last angle, which is GAF. And we can figure out what this angle is because it is in part of a right triangle. And we know that this angle up here is 36 degrees. So we're just going to take 180 and we're going to subtract 90 and then we're going to subtract 36. And that's going to give us our answer. And when you do that, you're going to end up with 54 degrees for our final angle. So that's how you can find the measurement of all these different angles inside of a regular polygon. Next, we're going to go over how to find the area of an entagon, which means polygon with any number of sides. And you can find the area of any regular, the key word is regular polygon here, by dividing it into congruent triangles. So we're going to find the area of one of the triangles, and they've highlighted it in blue over here, and then we're going to multiply that by the number of triangles. So we can take this and find the area of a triangle, which would be 1/2 the base, and they use S for the base because that's the length of our side, multiplied by A, which is our apothem. So in this formula, we have 1/2 times the side length times the apothem. And then we multiply that times n, which is the number of triangles. And you'll notice the number of triangles that are formed are going to be equal to the number of sides. And this one up here, remember, was a pentagon. So you'll notice that we ended up with 5 triangles. And that's going to be how we're going to find the area of our polygons today. So we're going to use that formula in our example. In the diagram, WXYZ is a square inscribed in circle P. We're going to identify the center, a radius, an apothem, and a central angle of the polygon. So it's important that you know how to identify these parts of the shape. So first off, our center is at point P. Then our radius, there are 2. In this one, we could do PY or you could do PX. I'm just going to list both because they're both there. Next, we are going to name an apothem, which remember is from the center perpendicular to one of the side lengths. So that one would be PQ. And then we're going to name a central angle. And remember, when you name an angle, you use the angle symbol. And the central angle is the distance or the angle between 2 radiuses that are consecutive to each other. So this one you can name XPY, or you could also name it angle YPX. But the P has to be in the middle because that is the center of our polygon. Next, we are going to find the measure of these different angles. And this one would be the measure of XPY, which is our central angle. And remember, there are 4 of those that could be formed in our polygon. So to find the measure of angle XPY, we're going to take 360 degrees and divide it by 4. And that's going to end up being 90 degrees. So we know this is a right angle on the inside. Next, they want us to find the measure of XPQ. Which is half of that distance. So this one would be 90 degrees divided by 2, which equals 45. And then lastly, we're going to find the measure of angle PXQ, which is this angle down here. And we know that one of the angles is equal to 90, so we would do 180 minus 90. And then we would subtract the 45 because we already found that. And that would leave us with a second 45-degree angle in our shape. So it is important that you know how to find these different angle measurements. So now, if you can go to your homework assignment, we're going to go over one of the problems on how to find the area of a regular polygon. So we're going to do, let's say, example 11 together. So first, we're going to draw a second radius here because we don't have one. And we need to find the area of this triangle. And remember, the area of a triangle is 1/2 the base times the height. And then to get the area of the polygon, you multiply that by the number of triangles that are going to be formed. And in this one, that would be 4, or just the number of sides. So let's start to figure out what we know. So if we were to find our central angle, we just did that in one of our problems, we know that that would be 90 degrees. And half of that would be 45. So we do have a 45, 45, 90 triangle here. And when we do that, we know that both of the legs are equal to each other, which means these are all side lengths of 4, making the entire base equal to 8. So in our area formula, we know that we're going to take 1/2 multiplied by 8. Then we need to multiply it by the height of the triangle, which luckily for us, they already gave us that value. And then we're going to multiply it by the number of sides or the number of triangles, which would be 1, 2, 3, 4. Once we have filled in all of our numbers into our equation, we can go ahead and find our answer. So 1/2 of 8 is 4. So we're going to end up with 4 times 4 times 4. 4 times 4 is 16. And 16 times 4 is going to be, let's see. Let's just make sure we do this right. 6 times 4 is 24. 4, 6. So we're going to end up with 64 units squared for our answer. So that's what you're going to do for 12, 13, 14, and 15. If you have any questions on these, let me know. Remember, for a lot of these, you are going to be using special right triangles. And remember with those, if we have a 45, 45, 90, we have a leg equal to a leg, so those are the same. And then the hypotenuse is equal to the leg times the square root of 2. And that's for 45, 45, 90. And then the second special right triangle that we have is a 30, 60, 90. So opposite of 30 would be our short leg. Opposite of 60 is our long leg. And then again, we have our hypotenuse opposite of our 90. So the two equations you need to know for this triangle is that the long leg is equal to the short leg times the square root of 3. And the hypotenuse is equal to the short leg times 2. And then don't forget that if you need, we also have our Pythagorean theorem, where we have a squared plus b squared equals c squared. So those might be helpful while you are looking for some of the side lengths to find the area of our polygons. If you have any other questions, just let me know and I'll get back to you.